Good evening, ma'am. Today I will be demonstrating the task M4.T1D. First of all, it is the explanation of the task that I am making an airport density analyzer using the MPI parallel computing. It reads the data from a CSV file containing the flight times and types, then distribute the workload across the multiple processor cores. Means the all of the flight data is being now in a single processor using the parallelism and the MPI program. And the each MPI process handles a subset of flights that count that how many of the flight will be fall into each hour. Like we have a hour slot from 0 to 23, or we can say from 1 to 24, and the data is being circulated into branches. Means in branches of each branch will count a subset of the flights, and then the hourly time slot, and then all the results are combined to a product into a congestion report showing which times are the busiest at the airport. For example, if there I will be the output will be run, and at the end it will show that in a slots of the timings and the hours, that in that particular hour that the particular flight and the particular terminal is now being busy, and the times are the busiest, that this to this time is the busiest time for the airport. The parallel approach makes analyzing the large database like thousands of the flights much faster than the traditional sequential processing. The working prototype means all level 1 requirement including the completion, the execution, the correctness verification and the stress tests are being included in this. So here is my Ubuntu. First of all, I will show you that all the explanation of the code which has been written by me. So it is my code. First of all, we will go on the define line, that is define n bins is equal to 20. It means that I have defined the number of 20 of the slots to the flight of the counting number that is being defined by the 20, means the number of the time slots are being 20. The second one is the simple flight structure. For example, I am creating a struct, means a struct creating my name flight, which will include the string ID, the integer name and the string type, and the counting of the passengers. Then we will come on the CSV file reading, the function to read the CSV file. Here in which what I am doing this code is that first of all it will create an open CSV file which is being created by a generated .data.py file, and then it will read each of the line, convert it into the flight objects, and then store into this in a vector. After that we will go on the next heading, which is the get line, file line and skip header. It means it will skip the line names. The get line, these are the same, the like SSF type, it is being here I shown here F type, STOI, F dot passenger, F dot passenger. It means the converting, it is converting string into an integer. After that we will go the flight attendant name, which is being now corrected by this, and then we will go for the initialization of the MPA broadcast. Wait a second. Here the initialization of the MPA for the rank and for the size, means the MPA has been initialized, it will start the MPA process. The rank will be process ID, which is 0 for the master, and then it will be the size. Then size is now the total how much of the processes are being checked. Then if argument is not equal to 2, that it ensures that MPI, that when I will run the MPI program, that MPI run with the 4 processes slash dot slash airport dot density, it will make sure that it runs. After that it is showing that if the rank is equal to 0 0, then why the only it will process only 0 read file, avoid the duplicate reading. And then the total flights, for first of all the I have for the 0 ranking I have given firstly initialize the total flight is equal to 0. Here initially the count of the flight is equal to 0, and then I am broadcasting the total number of 5 flights to the processor, means sends the total number of flights to all the processor involved in the task. And then is the distribution of the work. The int base count is the total number of flight by size, and the int remainder is the total number of flights and divided by rational by size, means it will divide the flight equally, and then which are the extra flights are then first few processes will get them. After coming to the rank and the remainder, if the rank is less than the remainder, then the my count will be the base count plus 1, means some processes will get one extra flight. In this way I'm using the scattering for scattering the object. Means when the splits after flight time, master will split the flight after the time and send chunks to the each processes. I'm in. Here is a create area. I'm creating an area for count for the scatter. First sending the count size and the displacement side by using the vector integer. Then I am finding the minimum and maximum for time work globally. Global min and max by using my max equal to reduce and using the function MPI all reduce and MPI all reduce for minimum and then for maximum. It will combine the all the processes and then it will find the global time range. After that I am creating time bins using the float bind width. Here is the formula. It will divide the time into equal intervals. In this formula, global max minus global minimum plus 1 by number of bins we have defined 20, so it will equally divide the time into intervals. Int bin is equal to time minus global min. It will assign each flight to a particular bin. And then it will combine the results. Here is the printing of the results. Sum of all the bins should be equal to the total number of flights. That's it. Control S, Control X. Then I had created a generate data.py for regular generation of the file for summing of the inverted intervals. Here is the generate file. We can see that import the random and sys on generating the data. Now we will run this. So here is the command for running MPI run. We are including the 4 processors for running this flight, and flight underscore 1k.csv is created by generating the data from the data.generate.py file. So here is we can see that airport data analyzer. Total number of flights read 1000 using 4 MPI processes. Total number of time ranges from 0 to 23. Number of total bins is 20 and number of bandwidth is 1.2 hours. We can see that the bins from 0 to 19 means total number of 20 bins, the time range and the flight count. These are the number of flight which has been included, and each flight is now given to a particular bin, and verification is that total number of flight counted is equal to 1000, expected also 1000, because we have defined here also the total number of flights to be read is 1000. After that all the flights were counted means everything has been correct, and on the basis of the analysis we can analyze that busiest time was 16.8 from 16.8 to 8 hours with 89 flights. It is here with the 89 flights from 19 to this, and this for the busiest hour analysis from 89 flights. Thank you.